Good morning, everyone. This is Mr. Onofrio. Hopefully, you've had a good day yesterday, and hopefully, you were able to learn a little bit about using our trigonometric ratios and choosing which one to use when we aren't specifically given one. Today, we are going to begin our new lesson, which is using inverse trigonometry to solve for angles of right triangles. So we are going to start on your first slide that says inverse trigonometric ratios. Before we really dive in, I just want to give you kind of a quick little reminder what it means for something to be an inverse. We work with inverse operations every day. Inverse operations are operations that undo each other. So some very common examples of inverses that you've probably seen: addition and subtract. We say all the time that to cancel addition, we can use subtraction, or vice versa. We could also say that multiplication and division are inverses. Another example, we could say an example of inverses would be 3 and -3. If you have $3 and then you add -3 to it, you've got nothing. They undo each other. We can also use what we call inverse trigonometric ratios. Normally, a trig ratio takes one angle and one side, and then it uses those to solve for a missing side. However, inverse trigs work the opposite way. They take two sides and then they solve for the missing angle. What we're going to do next is we're going to talk over some basic processes for these. Then we're going to work a few examples. You will have the rest of class to work on some problems afterwards. Feel free to pause the slide for a second to finish writing. Okay, let's move on. So we have three inverse trig ratios. We say, and we're going to say, let angle A be an acute angle. Now, to make our formulas a little bit easier, we are going to use the labels A, B, and C for our sides of the triangle. Now, we already talked about our three trig ratios and their formula. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. These all dealt with sides, right? These are all our sides. And we always had an angle as well, where A is the angle. What a trig ratio lets us do is it lets us rewrite our equation so we can get the angle by itself. For instance, to find the inverse tangent, we could say angle A is equal to the inverse tangent, which we write with this -1. So this is the inverse tangent. The inverse tangent of our opposite side over our adjacent side. For inverse sine, we could say angle A is equal to sine to the -1, or inverse sine of opposite over hypotenuse. And for inverse cosine, angle A is equal to cos -1 adjacent over hypotenuse. And notice that we could, if we wanted, we could plug in our letters for opposite and adjacent. So like our opposite side for inverse tangent, our opposite side of angle A is our little A over adjacent side would be B. For inverse sine, our formula could look like sine to the -1 of A over C. And inverse cosine would be the inverse cos of B over C. What I would like you to do, go ahead and take a second and pause this video, and then you can finish copying down what you need to. Okay, at this point, hopefully you have everything down that you need to, and we are going to go ahead and look at your next slide. We are going to start by solving problems number 3 and problem number 4. So let's look at problem number 3 first. We're given a nice triangle, and we are told that we need to find the value of x. Notice that this is a little different. For problem 3, our angle is in fact the variable here. So we have to approach this a little bit differently than we would our other problems. Now, last class, we talked about how we could choose which trig ratio would fit best. What I notice, we do have a hypotenuse. Our slanted side is the hypotenuse. So we can make a note and say our hypotenuse is 14. And then the last thing we need to look is to see, okay, do we have the opposite side or do we have the adjacent side? Our last number is across from the x, so we actually have the opposite side. Let's set up our equation. We know that since we have the angle, the hypotenuse, and the opposite, we have to use our sine function. So let's set it up. Sine of our angle equals opposite over hypotenuse. Fantastic. Let's plug in our values. Sine of our angle is x equals our opposite side is 9. We'll have 9 over 14. And our job is to get the x by itself. Notice we have no letters with the x, or no numbers with the x, right? Just this sign. So our thought, we can get rid of sine with sine to the -1. So what we can do is we can take our equation and we can apply sine to the -1 to both sides. And I know this looks a little bit messy. On the next problem, I'll show you a shortcut that makes it look nicer. Sine to the -1 and sine are going to go away. These cancel. And all we're going to be left with is x equals sine to the -1, 9/14. Okay, I don't know about you, but I can't do that mentally. So let's look at our good friend, the calculator. And let's see what happens when we plug some stuff in here. So as we plug in to type your sine, what I would like you to do is you can press the second key, second, sine. Press those, and you will see your sine to the -1 pop up. And then you can just type in your fraction, 9 divided by 14. Excuse me. Hit the equal sign, and there you go. You've got your answer. So for our first problem, x is equal to 40 degrees. And that's all we're doing here. Let's look at another one. Problem number 4 next. So for problem number 4, again, we are given x as our angle, and we have our two sides, 31 and 38. So as we make our notes, we can say our angle is x. We are given the hypotenuse. Our hypotenuse is 38. And our opposite side, and we're given the opposite side this time, of 31. So just like before, we are going to use sine. Let's set up the equation. Sine of our angle, sine of x, equals opposite over a hypotenuse. Opposite is 31, hypotenuse is 38. Notice how in our last example, after we did sine -1 after we tried to get rid of our sine, all we were left with is x equals sine to the -1 of our fraction. So what we can do here is we can kind of skip a couple steps, and we can rewrite this as x equals sine to the -1 of 31 divided by 38. Let's get our calculator out. Inverse sine of 31 divided by 38. It's going to give you 54. X equals 54 point, mine says 66. 54.66 degrees. Notice, since we're finding angles, we have to use the little degree sign. All right, let's look at another couple examples. The next two examples we're going to work are examples 9 and 10. So looking at example 9, again, given the angle x. Now let's look. What sides do they give us? Take a second. Take a guess for yourselves. Okay. I notice that they give us our long slanted side, the hypotenuse of 52, and our adjacent side, 44. Since we're given hypotenuse and adjacent, we can conclude that we need to use cosine. Let's set up our equation. Cosine of our angle equals adjacent over hypotenuse. Plugging in our blanks, cosine of x equals, adjacent is 44, hypotenuse is 52. Just like on our last examples, we can get rid of cos, our cosine. We want to get rid of cos using cos to the -1. So writing that out, we're going to have cos to the -1 of cos of x equals cos to the -1, 44 over 52. Cos to the -1 and cos, those go away. I'm going to be left with x equals cos to the -1, 44 divided by 52. And at this point, you can turn to that handy dandy calculator again. To type cos, you're going to type second cos, just as simple as that. 44 divided by 52. That's going to give me 32.20. X equals 32.20 degrees. Okay. Let's look at our last example, or our next example for today. We've got two more after this. Given X and our two sides. Our angle is X. Again, we're given the hypotenuse, which is 24, and we're given the adjacent side of 19. Same setup as our last one, so we can use cos. Cosine of our angle, cosine of X, equals adjacent divided by hypotenuse. Using our same trick, going from this step to this step, applying it here, we can rewrite our problem as X equals the inverse cosine of 19 divided by 24. So putting that into our calculator, inverse cosine 19 divided by 24 will give you a total of X equals 37.65 degrees. Okay, we've got two more examples to work, and then I'm going to be quiet and let y'all get to work on your extra practice. Our last two are 15 and 16. On both of these, we're given our angle. Our angle for both is X. And then we look and we're not given the hypotenuse. We're given our opposite side is 21, and our adjacent side is 25. So that tells us, since there's no hypotenuse, we have to use tangent. Our tangent formula, tangent of your angle, is equal to opposite over adjacent. Plugging in our values, we're going to get tangent of X equals 21 over 25. To get rid of tan, we can use tan to the negative 1. Our equation is going to become tangent to the negative 1 of tangent of X equals the inverse tangent of 21 over 25. We have our two pieces cross out. We're going to be left with X equals inverse tan 21, 25. Go ahead and plug that into your calculator. Second, tan 21 divided by 25. It's going to give you X equals 40.03 degrees. All right, let's look at our last one for today. Last one, hang in there with me. Our angle is X. We're given the opposite side of 6 and the adjacent side of 10. We can set, this tells us, again, we are going to use tan. We can set up our equation. Tangent of our angle, tangent of X equals 6 over 10. All right. We knew to get rid of tan, we could use inverse tangent. So let's do that same thing here. We can take the inverse tangent of both sides. We're going to the inverse tangent of 6 over 10. Plugging that into your calculator. Inverse tangent of 6 divided by 10. It's going to give you 30.96. 30.96 degrees. So these are inverse trig ratios. You may be wondering why we're going to be using these. These come into play on a lot of real world scenarios. It's much easier to measure sides than it is to measure angles. So it's nice to have a tool that we can use to figure out an angle once we know two sides. For the rest of class, I want you to work on the problems that we have not done together. Once you finish, you can turn in your assignment by setting it on my desk or submitting a picture on Canvas. You may also work on Dreambox today, trying to get your 5 lessons for the week. Have a wonderful rest of your day.